Ladies and gentlemen, welcome to It's Rainmaking Time. I'm Kim Greenhouse. For those of you that don't know, this is a show about new and ancient knowledge and discovery. We've had the good pleasure of interviewing heads of industry, leaders in practically every field in the world. And I want you to know that today's subject that we're focusing on is so important that everybody throughout the world in this and future generations needs to know about this. What we're going to talk about today impacts plants, animals, minerals, water, the water supply, your body, all animals' bodies that we can think of, bees, the bee population, all of agriculture, your well-being wherever you live, your biology, your physiology, your chemistry, your microbiome, your entire organ system. And before we introduce our beloved guest, a major research scientist who've studied this subject for over 10 years with degrees all over the place, I want you to know that It's Rainmaking Time's purpose in bringing this to you is not to upset you, but to make you aware of something that's been going on for many, many years that has an industrial foothold on all of life on the planet. And that we can do something both for our well-being, to the best that we can, and to step forward, raise our voices, and stand up so that this toxic, virulent chemical that has taken over the entire food supply and the water supply can be stopped. It needs to be stopped. And we're going to welcome today our beloved research scientist, Dr. Stephanie Seneff, who is the author of a book you all should have, if nothing more, that you are a witness to this kind of research, how serious this is, and that you never allow bureaucrats to get away with keeping this in the world. She's the author of the book Toxic Legacy: How the Weed Killer Glyphosate is Destroying Our Health and the Environment. She is a research scientist with many degrees. I hope I get this right. She has a BS in biophysics, an MS, an EE, and a PhD in electrical engineering, and in computer science, a PhD and an EE as well. I want you to know that, listen carefully, but know I'm going to cut in here a bit because she is researching science at over 100,000-foot level, meaning she's in all the details. She's in all the interrelationships between the parts. She's studying everything in sight at a whole systems level. She's turning over all stones that would benefit us, humankind, the plant, animal, and mineral kingdom, and the future generations of planet Earth. Ladies and gentlemen, welcome Dr. Stephanie Seneff to It's Rainmaking Time. Thanks so much.
That's quite an introduction. And
thanks so much for being here.
Hyping,
it's true.
I certainly hope people understand that it is incredibly important for them to get this message and then to act on it.
I want to talk to you first of all, and first I want to acknowledge that I cried a lot reading your book. And when I think about it, I could cry again because to be in possession of this kind of material is so shocking as to the effects that it's having on all biological systems. And yet we can see this inside products at the front row of like a Home Depot and other type of stores like that, Lowe's, Home Depot, wherever we depend on for construction, for planting. It's used all over agriculture. So I don't mind getting into all the weeds, but my purpose with you today is to bring through information for you to put together in yet another show that you've done, the connecting key dots to this, because nobody's going to get the science like you. There's so many interrelationships and layers. So I want to invite you to invite me to facilitate this on behalf of us average folks who need average people, on behalf of us average people who need to get the essences of this because it's such a toxic, virulent, destructive chemical in the market.
Right.
Okay, the first thing I want to ask you is, I want to talk about something that seems remote but is not remote, and that is, what does this chemical do to the soil and plants and agriculture? Explain it, because I understand it's a chelating chemical. Talk about
Right.
that.
Right. So it does several things, and certainly metal chelation is one of the very serious problems that it presents, because it's very good at binding to metals, and it's so good that it prevents other binders from getting to those metals, and it prevents those metals from being even taken up by the bacteria. Bacteria in the soil, the bacteria in our gut, they can't take up those metals, and then they get sick themselves because of those deficiencies that arise from that. So it's not just our own cells that get deficiencies in the metals, and also toxicities. It turns out it makes the metals simultaneously deficient and toxic, many of the metals, and that is a serious problem, because the minerals are so important. They catalyze so many of our enzymes. They depend upon things like iron and manganese and zinc, and they're all being chelated by glyphosate, and so they don't get taken up by the plants, and so the plants become deficient. Sulphur, for example, was shown. Professor Don Huber is the one who really introduced me to glyphosate, and he did a lot of studying on the plants to see what was deficient in the plants, and he found lots of minerals became much lower levels in the plants because of the presence of the glyphosate in the surrounding soil, and also when it messes up the bacteria that are concerned with, for example, nitrogen fixation. That's another problem, because it disturbs those bacteria, and then the plants don't take up nitrogen as readily as they should. So you have to use excess nitrogen fertilizers, and then those get washed off into the seas and cause disruptions there because there's too much nitrogen, which causes algae overgrowth, and you get a lot of problems with the red tide, all these different issues that you see, especially when it's hot, with the waters becoming toxic from metabolites that are produced by these microbes that are overgrowing because of the extra nitrogen and the extra phosphorus. Glyphosate actually provides both nitrogen and phosphorus to those organisms that are lucky enough to be able to break it down. Most of them can't break it down. It's just toxic to them. But cyanobacteria, for example, can break down glyphosate, and they do so, and then they release those nutrients, which causes this nutrient overgrowth that gets you into a lot of trouble with toxicity in the water.
You know, I interviewed Jeffrey Smith years ago, and we did a couple of shows together on genetically modified food and organisms. And I remember then him talking about how the bee population was actually being destroyed just from genetically modified foods and organisms. But when you add this chemical to it, talk about that for the bee population, because if they go, we're going. Talk about that.
And I was really surprised. I was following the whole thing about bee colony collapse syndrome and very disturbed by it, and all these issues around the insecticides, which is true. Insecticides, of course, it's an insect, so it's going to get affected by the insecticides, the bees. But the bees are also very susceptible to glyphosate. And that's another thing that Don Huber pointed out to me, and he's actually written about that. It's very clear to him and to me that glyphosate is a major player, possibly the most important player in the bee colony collapse syndrome. But it's being ignored because the governments are all being told that it's safe. So they're only looking at the insecticides, which are also a problem, of course. Between the two of them, the insecticides and glyphosate, the bees don't have a chance.
Aren't they like, is it 40 million bees or more, or have left? Like they're gone. What is the estimate?
I don't know the number, but it's a huge drop in the bee
or is it billions? I don't know how they even come up with something like that. But
I can't give you the number, but I know it's a huge drop, and it's really disturbing because we depend upon them so much for the fertilization of the plants, the pollen. They play a tremendous role there, and if they're gone, we don't have a good way to replace them. So we're going to have a problem with growing crops because of the lack of the bees. And we're not, the government is definitely not doing enough to try to fix this problem. The bees actually their gut gets disturbed by glyphosate, just as ours does, the gut microbiome. And there's studies that have shown that glyphosate causes the kind of a bee autism or a bee Alzheimer's disease in the bees. It causes their brain.
That's all we need. It's enough that people are scared of bees, but now we got them with Alzheimer's. That's not a good picture, right? That's really terrible. couple of months ago, I did a piece with Dr. Sabine Hazen on the microbiome. And at the time, she was speaking about her findings with regard to the COVID vaccine, that the bifidobacteria was completely disappearing. I think there was something else she said that was disappearing, another bacteria. And I was thinking, is she aware about glyphosate, the impact of that? Because how can you tell one from the other? In other words, they're all mixed up, right? We have so much glyphosate in us. Explain that about the microbiome and this chemical.
Yeah, she is aware because she and I have communicated, and I've told her about the glyphosate messing up the gut microbiome. And I suspect that she's been looking at bifidos before even COVID. So she's well prepared to see what's happening with COVID. But I think when people have a suppression of the bifidobacteria because of glyphosate, this makes them more susceptible to damage from the vaccine and from COVID-19 itself. So I'm really worried about that. Yeah, and I wrote about the bifidos way back when, my first paper on glyphosate with Anthony Samsel, I think in 2012, maybe 2013. I think it's 12, but
time flies as we get younger.
I know. Yes, we talked about the suppression, the bifidobacteria being especially sensitive to glyphosate compared to other species. And the bifidos and the lactobacillus, those two are particularly sensitive to glyphosate. Lactobacillus in part because of the manganese, because they really depend upon manganese, and it gets so badly chelated by glyphosate that they become deficient in manganese. That's part of the issue with lactobacillus. But the bifidos, they are so important in the gut. The infant gut is basically lactobacillus and bifido. They're the dominant species by far normally. And glyphosate's killing them off. And so other species gain footing and release toxic metabolites that can actually contribute to things like autism. So bifidos are really, really important in the gut. And they provide enzymes that break down, that help the host to break down all kinds of things in the food that are going to become important for health. You know, the bifido, all the bacteria actually are so important. We hadn't realized how important they were until we started killing them off like we're doing now. And you can see the number of papers on the gut microbiome has skyrocketed in the last 20 years. And I think it's because we're noticing what they do for the host because they're not doing it anymore and people are getting sick.
Do you know of a test that we can to check the amounts of this chemical, glyphosate?
You can get a urine test. You can actually get that, I believe, without even having a doctor's prescription. You can just order it online. I've done that, actually, just get a urine test for glyphosate.
Really? Do you think it's excuse me for asking this, but do you know who came up with that test?
Oh, I don't.
Trust
do you?
Well, no, but do you trust who came up with that test as a valid test? I'm sorry to ask that. I don't mean to offend anybody.
There's always an issue with any test as to the validity of the answer that you get. That's certainly true. And the other problem with it is that it's only a short-term measurement because the glyphosate comes and goes rather quickly. So it's really looking at the last 3 weeks of exposure. So if you've had very low exposure the last 3 weeks, but you got hit hard 2 months ago, you're not going to see that in that test. It's looking.
Does it bioaccumulate? I'm sorry, I didn't mean to interrupt you.
Well, it does.
It bioaccumulates, correct?
Yes.
Talk about that. Talk about that. That's important.
Well, that's the problem. That's the big problem, actually, because most of it comes in and goes out, and as it goes out through the urine and through the feces, but there's a certain percentage of it, and I don't know exactly what percent. It's small, maybe like 3% that sticks around. And those glyphosate molecules become a really big problem because and in my book, I talk extensively about my theory that glyphosate is substituting for glycine, the amino acid glycine, during protein synthesis. And this is a little bit of biology, but it's sort of basic biology.
We need it. We need it. Give me the basic. Give us all the basic one. We need something basic.
You have the genetic code, which is made up of 4 letters, which are the nucleotides that make up the DNA. And the DNA is the code of life, right? And so you have this sequence it's a code in letters. And it's quite fascinating how it works because it's a 3-letter code. 3 letters map to a particular amino acid. And there's about 20 amino acids, and they all have codes. And then, so when the machinery assembles the protein, it uses the code to put the amino acids together, and that makes the proteins. And the proteins are the workhorses of the body. They do so many things. They're the enzymes and the transporters and the structural proteins. They're just everywhere and extremely important to life. And glycine is the smallest amino acid. It has no side chain. And so it's used in the proteins in many different ways. It is essential in certain proteins. If you change the code and that glycine becomes something else, you can have a severe disease, and it can be, you can die at the age of 5 because of this one single mutation. In certain cases, there's some very, very important glycines in certain proteins that have to be glycine, or else that protein's dead in the water. And I've looked at those, and I've done a lot of searching for proteins that have essential glycine dependencies, because that starts to give me a hint as to which ones would be especially sensitive to glyphosate substituting for glycine. And so glyphosate is a glycine molecule. It also has no side chains, just like glycine. What it has is extra material stuck onto its nitrogen atom. And the nitrogen atom is outside of the socket where the enzyme is designed to fit the glycine very carefully. Smallest amino acid, you have the small space for the glycine. Glyphosate can fit into that small space. Its nitrogen is sticking outside, and so is the stuff that's attached to its nitrogen. It's all outside of that cavity. So glyphosate ends up being pulled in by mistake instead of glycine when they're assembling the protein. And you end up with a glyphosate molecule where glycine should be. And glyphosate has this methylphosphonate unit stuck onto the nitrogen, which makes it negatively charged, much bigger. It's not at all like glycine. And the whole point of having glycine is because it's really tiny. But glyphosate's not tiny because it has that extra stuff on the nitrogen atom that sticks out and causes trouble. And it blocks, binding of the substrate when it's at the active site. So it really can severely disable certain proteins when the glyphosate substitutes for glycine. And I have been able to, it's a giant puzzle, a jigsaw puzzle, and I write about it in my book, but I've been able to identify certain proteins that I think are being hurt by glyphosate such that they no longer work properly, and then causing disease. And all of these diseases that are going up exactly in step with the rise in glyphosate, there's a huge list of diseases. Glyphosate usage has exploded over the past 20 years. It's gone up practically.
Can you name a few? Can you name a few of those diseases? Yeah, that are really. I know there's a lot. I know there's a lot, but like whatever comes to mind to share with the audience.
Sure, diabetes, obesity, inflammatory bowel disease, irritable bowel disease, celiac disease, autism, Alzheimer's, Parkinson's disease, pancreatic cancer, thyroid cancer, bladder cancer, liver disease, liver cancer, kidney disease, kidney cancer. That's a partial list.
All right, we're all falling over now. Now I hear it can block. I hear that glyphosate can block the liver, like plug the liver. Is that true?
Yes, in fact, there's enough studies now to be very convincing, and I can remember one mouse rat study in which the rats were exposed to low dose glyphosate below regulatory limits over a period of time, and they were watching for fatty liver disease, and they found it. So the rats developed fatty liver disease, and that's another one that's going up. Fatty liver disease, which is a precursor to liver cancer. And liver cirrhosis, all of those are going up. We were having a lot of problems with our livers because glyphosate is really toxic to the liver. And so this rat study showed that it caused fatty liver disease in the rats. And then there was a really interesting human study that I really liked because it was compelling. I was surprised. They looked at people who had severe fatty liver disease, milder cases, and none. They had those 3 groups. They divided their population into those 3 groups. And they measured glyphosate in the urine. I was really surprised that they were able to get statistically significant differences between the amount of glyphosate in the urine for the good guys, the ones that were healthy, the ones that were in the middle, and the ones that were extreme. All 3 of them were distinguished from each other by significant differences in the amount of glyphosate in the urine, of course, with those ones with the worst disease having the most. I was really surprised that worked.
Wow.
Again, because that urinary glyphosate is such a short-term measure. It captured it.
I'm thinking here what to bring up next. There's so many pieces of this. I heard you on a show. I watched several shows with you on it. I mean, trying to study to prepare for you is like, I need a prize. I need a prize, ladies and gentlemen. You were talking, the gentleman, very nice guy, asked you about collagen, which so many of us are taking, I take it every day. When I heard you share that we're not like, I want you to say it. What happens if we're taking collagen powder? We think we're doing this good thing for us, but there's some complexity to this. Lay it out. You're going to upset us all, but go ahead, hit it.
Well, I guess the bottom line is I hope it's organic collagen, because if it's
How
not,
do
it's
we
probably
know? How do
contaminated.
we know? How
You
do we
can buy
know?
it organic. I think you can get organic collagen. I'm not sure as a supplement, but certainly if you eat, for example, if you buy grass-fed beef instead of the CAFO cows, which are loaded, they get tons and tons of glyphosate in their feed. The cows, they have all this GMO feed. And in fact, they're getting sick because of it too. And I know some people who are aware of these
And now they're
problems that
being
the cows are
injected
having.
with new mRNA
Oh, I
stuff.
know. It's an endless battle.
It's going to be
really
a Franken-cow. Franken-cow.
You're right.
So I'm looking at I don't want to bring it up because I don't want the company to be impugned, but I'm looking at collagen peptides, grass-fed, pasture-raised, but that doesn't tell us.
Good. No, that's probably good. I mean, that's about the best you can get, I think. So that's
Okay.
That's probably a good product. And I know a lot of practitioners, naturopaths that I know as friends, have told me that they prescribe glycine as a supplement, which is, of course, collagen has tons of glycine, and that's what makes it good for you. And the reason why people need glycine is because it can outcompete the glyphosate and help to keep the glyphosate out of the proteins. If you've got lots of glycine, then the enzyme, the assembly is much less likely to pick up a glyphosate instead if there's plenty of glycine. So you kind of want to flood the system with glycine in order to compensate for to keep the glyphosate out of the proteins.
Fascinating. You also talked about, actually, I saw Morley Robbins, who wrote a book on copper and the copper-iron relationship and metabolism. Also fascinating, different. And I heard him on a show say that he had spoken with you about what may be the role that glyphosate has with diminishing copper or increasing iron or something. What was that about, if you don't mind me asking?
Well, that's pretty interesting, because ceruloplasmin is the name of the protein, and ceruloplasmin is a copper carrier. I think it can hold 8 copper atoms in the protein, and all of those copper sites, the sites where it binds to copper, have at least one highly conserved glycine residue. In other words, it can be very susceptible to glycine substitution, preventing it from binding copper. So I think glyphosate is messing up ceruloplasmin, and ceruloplasmin is essential for getting getting copper distributed through the body. And it's also important for iron distribution. I remember that it facilitates the uptake of iron across the gut barrier, if I've got that right in my memory. So it becomes problematic for both iron and copper when ceruloplasmin is sick, and it can be sick because of glyphosate substituting for glycine.
Because I know that his body of work and calling is about demonstrating through his research that iron has taken hold and exponentially taken over the body because of a lack of, the copper's not being addressed properly in the relationship in the body. But then when you add this chemical, God only knows.
I think it's also disrupting the natural iron chelators that provide that ship the iron around. There's all this complicated biological mechanism for shipping these minerals around, because the body knows these minerals can be toxic if they're in the wrong place at the wrong time. They have to be sort of carefully sequestered and carried to the place where they're delivered to be able to serve the enzymes that need them as a catalyst. And iron is a good example. And in fact, it's ironic that we have an epidemic in iron anemia right now. Worldwide, there's a problem with a lot of people having anemia, but at the same time, there's a problem with iron overload, both iron overload and anemia at the same time. And that's the thing I'm talking about, is the glyphosate gets in there. It's like a bulldog. I mean, it just totally messes up everything else, because it's taking over on this system of bringing these minerals around the body. And it's botching it badly, because it doesn't know how to do it the right way as the normal chelators would be able to do it.
We're going to take a quick break, and we'll be right back with Dr. Stephanie Seneff. We're going to take a few minutes, and I'm very excited to talk to you about the Rainmaking Company. Many, many years, I helped other people bring their products to the market, helped them package them. They were usually very big international projects, whether they were scientists or inventors, pioneers. Those are the people I was attracted to assisting. Those are the people that I really understood, and those are the people I helped with their work. The Rainmaking Company is doing something very different now. I'm at a different age, at a different time. And right now, I'm offering communication, consulting, coaching, and packaging services to help you perfect your communication and to not only perfect it, but to be effective at doing it and getting the results that you really want. The other thing I'm doing is I'm for the first time offering official personal life guidance services. I've never done this on an official basis, and I don't know why. For some reason, I didn't want anybody to know that I provided this as part of my business advisory services. And life coaching became so proliferated, I was like, I don't want to be another life coach. But the fact of the matter is I'm a great life coach, and I've helped people dramatically in their lives. And so I want you to know that whether you come in through via communication services or you come in via the webinars, that's something that I am letting you know that I'm available to provide. And I think that one of the most important things in transmitting rainmaking is that rainmaking is not just the art and science of delivery. It is. To most people in the world, they think it's the art and science of delivering. But that's the distinction that I'm teaching people, that to be a rainmaker is a sacred promise. Whether you lose your job, you lose your company, you lose a key member of your team, rainmaking is rainmaking is rainmaking. It doesn't matter whether you have this credential or that credential, or you're way high up or you're way low in terms of your status, your track record and credibility. If you train to be the best rainmaker that you can, you will survive and thrive anything that happens in the global systemic change events, geologic events, the loss of property, the loss of possibly even your rights. We are at such a critical time in history that if you train to supercharge your rainmaking capability that all of us are born with and have. It's just a question of how much is activated, how much is strengthened. You will be good to go in the coming century. And you will find that you can do things you never thought you would do before. I'm doing my first webinar in years that I'm teaching in July. I'd like to invite you all to attend, let your friends know about it. And there'll be a whole series, but this is the first kickoff webinar. Also, go to rainmaking.ch, where you can see the breakthrough communication services. I've done several videos where you can get a sense of where it might be going, and the life guidance services and the webinars. There's also a special piece there for people that have made commitments to bring in solutions for the world. There's something kind of special on the site for you, too. Thank you very much, and let's get back to the show. All right, we're back with Dr. Stephanie Seneff, and we are going to go to, is there anything else you wanted to say about that? So so it's a copper-iron relationship, but glyphosate actually gets in there and wreaks havoc with all of it.
Yeah, exactly.
Basically.
It's just mismanaging. It's causing a severe disruption of the way the body normally handles these minerals. The same is for manganese. I wrote a paper together with Anthony Samsel on manganese. It's really quite interesting because I believe that the glyphosate is preventing manganese from going through its normal circuit. And that's partly because it disrupts the bile acids, because manganese is usually, it comes to the liver and then it gets packaged into the bile acids by the liver and then shipped back to the gut. And then it gets distributed through the body via the bile acids going into the chylomicron. It distributes the manganese throughout the body into the blood system. That whole pathway gets blocked, I believe, by glyphosate, because glyphosate disrupts the enzymes that make the bile acids. And then the manganese becomes toxic in the liver. And the liver basically just ships the manganese up the nerve fibers, up the vagus nerve, for example, and ships it to the brain. And then you get excess manganese in the brainstem, and you end up with manganism, which is like Parkinson's disease. So I got this idea from reading about welders, because welders, they get exposed to a lot of manganese because they're drilling metal, and the metal's dust gets into their nose, and then it travels down the olfactory nerve and gets into the brainstem and causes this condition called manganism, which is a whole lot like Parkinson's disease, but it's just a different part of the brainstem that got affected because it came in from the olfactory nerve. But Parkinson's disease has been very strongly linked to the gut. And then there's a theory that it's a communication between the gut and the brain along the vagus nerve that delivers for example, manganese to the brain from the gut to cause toxicity that can lead to Parkinson's disease. So that's a theory that we developed in the article that we wrote, suspecting that, I mean, glyphosate has been linked to Parkinson's disease as well in the farmers. So we have support for that.
Do you sleep at night? I'm going to ask your husband if you sleep at night. You sleep at night?
Pretty well, actually.
Do you?
I do pretty well with sleep. Yes.
I'm impressed. Let's talk about the thyroid, because this, okay. I mean, Hashimoto's and all the things that have gone on with people's thyroid, you know, it's like some people may be hearing this as like, oh, it's a one-trick pony. You know, it's like glyphosate has all this. But really, when you said in the book, diabolical, this is really diabolical.
I think so.
It's pervasive into everything.
Yeah, and the problem too is that it doesn't bowl you over. Like, it's not like so toxic that you're throwing up or something like that. You're not aware. It's a stealth poison. It slowly gets into all your tissues and messes things up in all kinds of weird ways. And then you get various kinds of diseases. There's like so many different conditions that it affects that people kind of think that can't be true. You know, there's a level of disbelief when you say all those diseases are being affected by glyphosate. And I think it's true. And I think it's because of the complexity of the type of poison that it is, that it can get into the proteins in place of glycine and mess them up. And then there are so many different proteins that depend upon those glycines and that become disturbed because of the glyphosate. And then it's just all these different diseases that come about because of it. Is really amazing. And thyroid is one of them. And certainly, and that connects to autism too, because women who have hypothyroidism have a fourfold increased risk of having an autistic child. And as you probably know, I believe glyphosate is the primary cause of the autism epidemic. That's been my big thing ever since I discovered glyphosate. I really believe it is the primary cause, and not the only thing that's causing the autism epidemic,
right,
but the most important one.
That's pretty powerful. I mean, that's really, really powerful. I'm sure the farm industry loves you, deeply loves you. What do you think about, I think you shared with me, if a mother is hypothyroid,
yes,
the child is more likely to be?
Just fourfold chance of having an autistic child compared to a non-thyroid problem.
Wow.
Mother. Yeah.
Wow.
Increased risk. And also studies have shown that glyphosate disrupts the thyroid. Again, studies on rats, and have shown the offspring of the parent rat that's exposed to glyphosate in utero while the pup is in utero, that disrupts the thyroid metabolism of the rat, the pup that's born in that environment where they're being exposed to glyphosate only while they're inside their mom's body.
My mother told me I had 17 blood transfusions at birth.
Wow. You're lucky to be alive.
I was in the paper, quite fat I was. And well, not that I'm thin now, but anyway, I maintained the pudge. But they said I was a miracle baby. And the Red Cross saved my life at that time. My mom was RH negative. I was RH positive. And I was born jaundice. And in those days, sometimes the mother would pass. It wasn't 100% clear what was going to happen. So it was big trauma. I was in the hospital for 3 weeks.
Wow.
I wonder, So you don't know what you're getting really.
Such an interesting beginning of your life, and what your
I
little
know.
that little infant
I
is
know.
thinking about the
Believe me, if
world,
they had said, I probably looked at the contract and said, I don't know. I don't know about this. Are you
You
sure?
were
Yeah,
a
I know you're going to
fighter.
have a great time. Go for it. It'll be a great adventure. Somebody kept the fine print away from me. They lied. Okay, so anyway,
It's a good
but
thing you can't remember, right?
I know. I know. Sometimes it's really a benefit not to remember.
Mhm.
Um, you talk at length, you share at length about the water supplies. What has happened to our water supplies? Now, I know that you know the level at which our water supplies have a lot of toxic chemicals in them.
Right,
I mean,
right.
okay. And that even the water that gets delivered through the sink, anywhere in your house, your apartment, etc., has a ton of chemicals.
Mhm.
And so we know that nothing's been done hardly anything has been done about that. So when you combine, I mean, we're like a chemical soup. When you combine the traditional water that people are drinking, and then you add this chemical, glyphosate, now
Yeah.
what? What are we looking at?
Well, there's a real serious problem, I believe, with the lead pipes. And, Flint, Michigan had that big show about too much lead in the drinking water in Flint, Michigan. And they had a big, it was big news. And I looked into that at the time because I suspected that glyphosate might be playing a role. And I still believe that's the case. I never tried to, I don't believe I ever said anything, well, I might have said something in podcast interviews actually about it, like I'm doing right now, but I haven't published anything on it. But I do believe it's possible because it turned out they had changed the water supply for Flint from one. They shut down one supply and brought in another one that was from a river that came through all this country where there were all these GMO crops growing. And so I think that the water was picking up glyphosate when it went through the farmland. And then the facility that was supposed to purify the water was kind of subpar. They kind of dusted something off that was old and didn't quite finish fixing it. And that normally would add. It's interesting because you normally add chlorine during the process of preparing the water to be safe to drink. They use chlorine in these facilities, and chlorine actually breaks down glyphosate. Non-enzymatically, it breaks down glyphosate. So inadvertently, they're doing the chlorine to kill the bugs so that you won't get some kind of infection, but they're also killing the glyphosate at the same time. So I think we're very fortunate that they do use chlorine, even though chlorine itself, of course, is not good for you. But they use chlorine in the water supply to purify it, and it removes the glyphosate. But I'm suspecting that that water that was going into the lead pipes had didn't get the glyphosate properly removed. And then the glyphosate it was first patented as a metal cleaner because it'll strip metal from pipes. So it's going to strip the lead off of those lead pipes and I think greatly increase the lead content of the water that ends up in the faucet. I'm suspecting glyphosate was a major player in that whole fiasco in Flint, Michigan.
You said to me in our first talk, before I had a technical malfunction, that glyphosate isn't in antibiotics. It is an antibiotic. Did I get that right?
You did.
Oh
Yes,
my
it's an
God,
antibiotic.
explain this to people, please.
Yeah, it's been
Explain.
patented actually as an antimicrobial agent. So it's had several different patents. Of course, one is to kill weeds, but there's also the chelating aspect for the metal pipes, and then the antimicrobial. So essentially patented as an antibiotic. And it's actually, a study was very interesting because they showed that when you expose these, and I forget which microbes it was, but they were pathogenic microbes exposed to glyphosate, low dose glyphosate over a period of time, and those bugs that got smart, they actually mutated to provide these new
Oh my God.
capabilities to actually to push out the glyphosate, and at the same time to push out all these other antibiotics that we normally would use to treat the disease. And so they became much more skilled at becoming resistant to the antibiotics that we would use to kill them as a consequence of their exposure to glyphosate. It's really interesting that there is this biological capability of getting a generic solution to a toxin that you're exposed to that ends up actually protecting you from antibiotics. If you're a pathogen, that's not good because then they become resistant. And I think that we have a lot of issues with all these antibiotic resistant bugs that are becoming impossible to treat. And I think, again, I think glyphosate's a major player in that. And also, of course, in the animals, they're getting all kinds of glyphosate in their feed, and they're also
Oh my
getting
God.
antibiotics. We're giving the cows antibiotics on a regular basis. I guess it's because it makes them grow faster or something like that. They use it maybe just prophylactically to keep them from getting sick, but they give them antibiotics even when they're not sick, and they give them glyphosate. And so they're training the bugs to become skilled at
Wow.
resisting the
Wow.
antibiotics.
Are you familiar with Dr. Ben Beckman?
Name sounds familiar, but I'm not sure.
He reminds me of you, your level like this, but his area is in fat, metabolism, fat cells, everything connected with body fat that we don't
Hmm.
understand, don't know.
Mm,
He's in Utah. He's a research scientist, remarkable.
mm,
And I'm wondering if this chemical hangs out in the body fat, because don't we
mm.
hear that a lot of toxins hang out in body fat? So
You're right.
when you lose body fat too fast, a lot of people have what do you call it, or some type of reaction sometimes if they lose
Yes,
it
you're
too
right.
fast and
There's
they
a
don't get it out of the system, because what comes with it is the chemicals. Am I right or
yeah,
am I wrong?
you're close. Let me see if I can
Close. I
explain.
want a cigar. Come on.
So there's a lot of fat soluble toxins, and in fact, many of the insecticides are fat soluble, and they tend to accumulate in the fats. And that's actually a skill that the body has to trap them in the fats in order to sequester them and keep them away from the circulation to protect the host. I think a reason to get fat is to hide these chemicals in the fat molecules so that you in the fat cells so that you won't your body won't be exposed. And so when you lose weight, you release those toxins along with the fat, and then you get sick. That's what can happen if you lose weight too fast. Glyphosate is actually not fat soluble, it's water soluble. So it
Oh,
doesn't accumulate in the fat the same way the other cells do, but I think it does accumulate in the fat cells anyway, partly by getting into their proteins, but also Anthony Samsel believes that they attach to the fat. You have these lipids, which are phospholipids, right? Phospholipids. And the phospho is phosphate, which is attached to the lipid. And he's collaborated with me in a number of papers. He's a chemist and a toxicologist. And he believes that glyphosate is actually substituting for phosphate because it has that phosphonate unit, which looks a whole lot like phosphate. He thinks that that's binding to the fats to make a glypho let's see, phospholipid, glyphospholipid or something like that, pretending to be phosphate, basically. Just as it can pretend to be glycine, it can also pretend to be phosphate from that part
wow. It's
that's stuck
stealthy,
onto them.
stealthy.
Yeah, and then in reacting with the fats and getting trapped to them that way instead of because they're fat soluble. So different mechanism, but it does show up in fats because they have the government has limits for how much is allowed in things like soybean oil, for example, or canola oil. Those are both GMO Roundup Ready crops, and they have limits, which means they found it in the oil. So even though it's not fat soluble, it's in the oil, and I think that makes sense if it's binding because of that phosphonate that's substituting for phosphate.
I had to ask you about body fat because I actually was told that years and years and years ago, but typically you don't see people dealing with the chemistry of body fat and the metabolism of body fat and all the chemicals that are at work and the things going on, all these mechanisms. That's why I thought I asked you about Dr.
Yeah.
Ben Beckman. He would be interesting for you to talk with
Yeah,
behind the
I think
scenes.
I
I think
have seen
very,
some of his work,
yeah,
and I'm
he's
interested in fats myself. And also, I will say that glyphosate disrupts the metabolism of fats, and I think it's messing up the enzymes that break down the fats. And Anthony and I had written about that in one of our papers, because again, the glycine issue can disrupt those enzymes and end up having, and also the bile acids, because the bile acids play an important role in fat metabolism, and glyphosate suppresses the enzymes in the liver that make the bile acids. So when you don't have
what is
enough
it
bile
called?
acids,
What is it called?
bile,
Okay.
acids,
Okay,
acids.
bile acids. You said it so fast. I thought I was on a high speed
People can get
starship.
bile duct problems. They can get gallbladder problems because the gallbladder is not the bile acids are not moving, and then you get kidney stones or gallstones because the gall is the bile acids aren't flowing, and therefore you get these stones building up in the gallbladder. A lot of people, that's another thing that's going up, I think, is the gallstones, problems with the gallbladder, that's connected to poor bile flow because the enzymes that make the bile acids are broken by glyphosate. And those are the same enzymes. They're very important. They're called cytochrome P450 enzymes in the liver. And glyphosate's been shown to suppress them. And they do several things. One is make the bile acids, and one is to detoxify the fat soluble toxins. So they turn them into water soluble toxins by virtue of these enzymes, these cytochrome P450 enzymes. So when those aren't working, the fat soluble toxins become more toxic. They end up getting stuffed into the fat cells because there's no way to make them water soluble so they can be sent out through the kidneys, through the urine.
Wow.
So that's a
Dr.
problem
Ben
too.
Beckman you need to talk to Dr. Ben Beckman immediately. I want to talk to you also about, we're going to get to deuterium because I know you're very, very
I love
excited about deuterium. We're going to talk about that in water. I've interviewed, I don't know, maybe 16, 17 water scientists, Gerald Pollack, Dan Nelson.
Yeah,
it
good.
goes on and on and on. And but before we get to deuterium, I want to ask you about the role of sulfur and how eating plants and vegetables with sulfur in it can help us, or can it help us?
Right. It's very important. I think sulfur is an overlooked nutrient. We don't even have a minimum daily requirement for sulfur. I think the government assumes we're going to have plenty. And normally that would be true, but Don Huber showed that glyphosate greatly suppresses the uptake of sulfur into the plant, so the plants become sulfur deficient. So if you're eating those plants that have been exposed to glyphosate, you're going to be sulfur deficient as well. But the other problem is glyphosate messes up the sulfur system in a huge way. And I wrote quite a bit about that in my book. I'm convinced that that's one of the big reasons why autism comes about. And it's really fascinating with autism that it's been shown both in rats. They have these autistic mice that they can create, genetically. And
poor mice.
And so those mice, as well as human autism patients post-mortem, so after they die, they look at their brain. And in both cases, they found out that there's very low heparan sulfate in the brain ventricles. It's very low. And heparan sulfate is a really important heparan sulfated molecule that's all over the blood supply, everywhere, and elsewhere as well. But it's really important for the circulation, but it's also really important for the growth of the neurons during in utero. So the whole maturation of the nervous system depends upon this heparan sulfate that is deficient in both humans and mice when they have autism. So it really points to something about sulfation as being a problem. I think impaired sulfation pathway is an essential part of autism. And I think it's caused very centrally by glyphosate. And I talk in my book about all these different enzymes that are involved in sulfur metabolism that have these highly conserved glycine residues that if you replace that glycine with something else, that enzyme's dead in the water. So they could, or even becomes, counterproductive. So all these enzymes that are involved with managing sulfur and making sulfate and passing sulfate from one molecule to another and delivering it, to the appropriate place, like putting it into the heparan sulfate, every step of the way, I think glyphosate's messing up those enzymes. And so as a consequence, yeah.
No, go ahead. No, go ahead.
So as a consequence, you have insufficient sulfation of the heparan sulfate lining all the blood vessels. And that is a very serious problem because that gets into the gelled water. And the sulfate is what makes the water gel along the edges of the blood vessels. And if you talk to Gerald Pollack, you know about that sort of thing, that there's all this gelled water that is so important in biology and normally would form like a jello layer along the edge of the blood vessel, so the red blood cell can just scoot right through like sliding on a slide because it's practically frictionless. That makes it very easy for the blood vessels, for the red blood cells to get through the capillaries because of that gel. But if that gel's not working well, then the red blood cell gets all tangled up in all these different molecules that are sticking out along the edges, and so a thin glycocalyx and I just read an article that was quite fascinating that showed they actually looked at from blood vessels, I think taken in here somewhere, they had access to these blood vessels and they looked at the thickness of the glycocalyx. They had a skilled, really fancy way to do this. And they found, and they looked,
I'm sure they did.
for 6 years after they tested them. And then they found that the ones that had very thin glycocalyx, which means sort of very insufficient sulfate and therefore not as much gelled water, had a six-fold, I believe, increased risk of various kinds of cardiovascular problems.
Fascinating. So the takeaway in terms of sulfates and the message is what? What do we do to
Yeah,
get
well,
more
the first
sulfate
thing
in
is
our system?
eat an organic
Asparagus?
diet. Eat an
Right.
organic diet, number one, because glyphosate is going to mess it up. If you have too much glyphosate, you're going to be very sensitive to sulfur. It's going to make you sick. And a lot of people
Really?
say, I have sulfur sensitivity. I try to avoid foods that contain sulfur. A lot of people say that.
Wow.
And that's because of those enzymes, because when you don't have a functioning sulfite oxidase, sulfite becomes very toxic. It's a very react. There's a lot of systems like this actually, where the one molecule
Fascinating.
is very reactive, and then there's an enzyme that normally takes it away really fast and turns it into something very useful. So sulfite to sulfate is a good example. And another good example I'd like to bring up is acetaldehyde. Acetaldehyde, it gets converted to acetate by an enzyme called acetaldehyde dehydrogenase. And
We're not going to remember this, but I know there's a point here. Go
I
ahead.
believe glyphosate is suppressing that enzyme and making the acetaldehyde toxic in the liver, which can cause liver disease and then ultimately liver cancer. Acetaldehyde is produced from ethanol, which is, of course,
Oh my
alcohol,
God.
by
Hmm.
another dehydrogenase. And glyphosate messes up many, many dehydrogenases. I have seen both a soil bacteria study and a study on E. coli. And both of those studies showed a whole big list of basically generically all the dehydrogenases were getting suppressed by glyphosate. And that is really, really scary because those enzymes, and we'll get to deuterium, they're very important for the deuterium system. But the acetaldehyde dehydrogenase is what keeps the liver safe from alcohol. So you can drink a lot of alcohol if you've got a healthy version of that enzyme. If you don't, then watch out. But glyphosate
Fascinating.
suppresses it.
Fascinating. Okay. Let us talk about deuterium.
Okay.
Let's start with a reference point for the audience. I've heard of deuterium depleted water, but most people don't have a reference point. Like, what is deuterium? What are we mostly drinking, et cetera? I had one question before this. I'm sorry. I'm going to take you back a minute. When most of us, even when we have filtration systems at home, we're still getting glyphosate, correct?
Depends. If you've got a reverse osmosis filter, that'll take it out. But it unfortunately takes out all the minerals as well, so you have to put them back in. It practically, I mean, it produces very pure water, but it's the minerals are important actually in the water. So mineral water is very healthy as long as you can
Oh,
keep the glyphosate out of it.
it sounds like a Cirque du Soleil 24 hours a day to be well,
I know.
right?
There's so much
Flying
effort.
and
Well, in today's world, there's just so many toxic things around. I really think the chemical industry, they've been running for 100 years too long. They've taken over the last 100 years. It's just been incredible how many chemicals are being poured out every day and
did you ever
inadequately studied.
did you ever meet the late great Dr. Nicholas Gonzalez?
No, no, but I know
He
about
used
him.
to
Yeah.
he I interviewed him 3 times.
Mm.
He had cancer patients coming to him in New York, and they were being alive and well 30, 40 years after being diagnosed with pancreatic cancer, something that usually goes 6, 7, 8 weeks and
Mhm.
someone's gone. And I just wondered if you knew about him, et cetera. I have a feeling, I don't remember if he knew about glyphosate, but I'm sure he
Mm.
did. I'm
He
sure he
probably
did.
did. Yes.
Yeah, because I would imagine it would be a vital piece of the whole, equation, the puzzle, as you
Yes.
say,
Yes.
to fast acting pancreatic cancer to get in there in the organ systems and
Absolutely. Yeah.
bioaccumulate.
Right. Yes.
All right. You are the deuterium goddess.
Yeah, I have to
I know
say,
you didn't.
I've
So,
had various moments in my life when I meet somebody and they say something, I'm like, oh my God, it's just like an epiphany. And one was with Don Huber. He gave a 2-hour presentation, 2012, September. I remember it well. And that was when I first heard about glyphosate. And I was like, oh my God, this is it. With the autism epidemic, I was so sure. And then I went back and studied it every which way. And basically now I feel like I've practically proved it. I have a new paper out together with colleagues on glyphosate and autism. Very long and complicated paper with all kinds of different stories about the metabolic pathways by which. And I think it's just so clear, it's so strong that I really hope that the world will wake up about that, because autism is such a serious problem right now in this country, and it just keeps getting worse and worse. And we can't keep this up. It's, it's going to ruin the country if it keeps on going the way it is. It's really a very big crisis, and the government seems to be happy to ignore it, and it just really annoys me that they're not rising to the occasion. They should be so
You
worried
know the
about it.
word safe and effective. Safe and
I know.
effective. It's
I know. That's right.
all
Yes.
safe and effective. Depends what your intent is, if it's safe and effective. Safe for
Yeah.
whom? Yeah.
So the deuterium, so it was similar, was just an email message that I got from Laszlo Boros, a professor at the time. He was a professor at one of the public universities in California. I think it was UCLA, but I'm not sure. And now he's back in Hungary, where he was born. He was educated in Hungary, and he really knows deuterium. And it's practically unknown even by the researchers in the United States. Very few people are studying it, which is a big mistake, I believe. I really think that deuterium is a very major component of the underlying cause of so many problems that we face today. And deuterium is not by itself the problem. It's because of what glyphosate does to the deuterium system. Just like it messes up the iron, so it becomes toxic and deficient at the same time, it does the same thing with deuterium. So deuterium, what is it? It's heavy hydrogen. Hydrogen is the smallest atom on the periodic chart. It's the upper left-hand corner. One proton and one electron, a really tiny atom. And by far the most common atom in our body, like over 60% of our atoms in our body might even be higher than that, are hydrogen atoms. They're just everywhere. They hook onto carbon, and they hook on, carbohydrates, right? That's carbon, hydrogen. They're in water, right? H2O, 2 hydrogens for every oxygen. So you can see there's tons and tons of hydrogen in our body. And everywhere hydrogen goes, deuterium goes. Deuterium is heavy hydrogen. It has an extra neutron. So it's twice as heavy as hydrogen, because the neutron and the proton are about the same weight. And it binds more, it's stronger binding to wherever it hooks on. So if it binds to a carbon, it binds more strongly than hydrogen does. And if it's doing an ionic bond, like 2 hydrogens attached to each other, it does a weaker ionic bond, like hydrogen to OH. It does a weaker ionic bond and a stronger covalent bond, which is what's carbon attached to hydrogen. That may be some chemistry that people don't know, but but it really behaves.
100,000 feet. Can we bring you down to 40? Go ahead. Try not to drop out of the sky. Okay, go ahead.
It behaves differently from hydrogen, and it goes everywhere hydrogen goes. So there's a problem, because the enzymes that depend upon a hydrogen being at a particular spot, if it's a deuterium, it can flummox them. They might not know how to do it with the deuterium instead of hydrogen. So, and in particular, the critical take-home message is the mitochondria. And the mitochondria are those little organelles inside the cell that are responsible for making lots and lots of ATP, which is the energy currency of the cell. So the mitochondria are spewing out all these ATP molecules very quickly using this enzyme called ATPase. And that enzyme, it depends upon what's called proton motive force as the energy to make the ATP. And the proton motive force comes about because these protons are pumped into the intermembrane space of the outside of the mitochondria. The mitochondria have a matrix in the middle, and then they have this membrane, but the membrane has an inside part to it. And all these different enzymes push protons into that membrane to make a really high concentration of protons there. And then those protons come out back into the matrix through those ATPase pumps, and they're basically pushing the pumps. They're actually spinning the wheel, you could say, of the pump to give it the energy it needs to make the ATP. Does that make a sense at all?
I mean, the mechanism makes sense. All the elements you just described is like a whole orchestra of things that you just described.
It's an activity that goes on all the time in the mitochondria to make the ATP, which is how the cell's going to get its energy. So obviously, it's really, really important. That's a super important enzyme in the mitochondria. And the problem is that the deuterium, it's big and bulky, and so it gets stuck inside the pump and stalls the pump. and then eventually can kill the molecule, so they have to make a new pump. So there's constant, and it also introduces reactive oxygen species. So you get these oxygen metabolites that are really toxic to the cell. Have you heard of ROS, reactive oxygen species? Because
I
that's sort of
haven't.
in chemistry, in biochemistry, that's a common term for these reactive molecules that are based on oxygen, like O2. You can have superoxide and O2 minus, what's it called? Yeah, oxide ion or something. Yeah, various radicals, oxygen radical and superoxide, hydrogen peroxide. These are all basically oxygen and hydrogen that are very reactive molecules. And so those are constantly a problem in the cells, but they become a much bigger problem if those pumps are getting hit with a lot of deuterium. And it's a consequence, the whole cell machinery kind of obsesses on making sure that the protons that end up inside that intermembrane space are not deuterons. It goes really hard, works really hard to make sure they're not deuterons.
So let me see if I understand a part of what you're saying that I think is key for us to receive from you, which is that this deuterium interferes with mitochondrial metabolism, chemistry, everything.
Sure. Yeah.
And deuterium follows or flows with hydrogen, correct? Am I correct on that? And
it's natural.
And it's natural. And I think a lot of us thought hydrogen is good.
Right.
People are taking pills, hydrogen water. So what's the story with that?
Good. I think that it is good, and I think it's because of the gas. And actually, this gets right back to this article that I found from the 1960s. It's a really cool article where they looked at microbes, and they specifically were looking at hydrogen gas that's made by the microbes. So the microbes have this enzyme called hydrogenase. The microbes in our gut, some of them have this enzyme called hydrogenase, which is actually very important in our gut. And our cells don't have that enzyme. So we can't do this, but there's many things that we can't do that our microbes can do. And that's one of them, which is to pull the hydrogen off of these organic molecules and pull it off of the carbons, put two hydrogens together and make hydrogen gas, H2. And hydrogen gas is naturally in the air. It's a certain component of the air, so it's around. And so the microbes make the hydrogen gas, and then other microbes use that hydrogen gas to reduce carbon dioxide to methane. So it's really fascinating, all the different gas activities that go on in the gut. But this business of making the hydrogen gas is very important, because this article from the 1960s, and I have not found anything since then, I've looked, it showed that gas that was made by those microbes was depleted by 80% of the deuterium. 80% of the deuterium went missing when it made the gas. And it makes sense, because the deuterium tends to stay with the liquid phase, because it's heavier, it sticks harder to all the reasons why it's physically different from hydrogen would make you believe that it would in fact be more reluctant to become hydrogen gas. So the H2 had very few Ds in it, D for deuterium, like HD, for example, very few, compared to what was in the molecule that it was taken from. So it's basically producing a low deuterium pool of hydrogen as a gas.
So how do we get sense? It makes sense if I was at your level of 100,000 feet, and if the audience is, but if we bring us down to 40,000 feet, I'm going to try to ask you a question and clarify the 40,000 footer. We're going to bring you down. I remember there was a wonderful guy named Ralph Ungerman that I met many, many years ago when I was I wanted to build this video network. And he kept going, when I shared my vision, he kept going, bring it down. It's too big. It's too big, like that. He would go, and I feel like I'm Ralph Ungerman talking to you. Yeah. All right. So what needs to happen in the water supplies to extract deuterium from the water supplies, or to help us have deuterium depleted water? What is the answer to this? What is or multi-path to this remedy? Is there a remedy?
Well, that's a hard thing. Let me just back off and say there are some. So seawater has about 155 parts per million of deuterium naturally in seawater, 155. So that's kind of an average benchmark for everything. Certain foods have a lot less than that. And in fact, fats have a lot less typically. If they're made organically, the fats will have more like 110 parts per million. So by eating a high fat diet, you're actually eating a low deuterium diet, which is quite interesting. So butter, lard, um, ghee, the ghee and coconut oil, actually, those are all low deuterium nutrients, interestingly. So they're all basically animal-based fats, but also some of the plant-based fats, low deuterium. And even like the chlorella, I think the chlorella probably are producing a low deuterium fatty acid that you eat when you eat the chlorella. So there's ways to get foods that are low in deuterium. And then low deuterium water is found naturally in interesting places, which is, for example, glacier melt.
Hmm.
And so people who live in Iceland, there's people have been interested in studying the Iceland folks because they have a very long life expectancy, very low infant mortality. They have a lot of good numbers with their health in Iceland.
I think we
And
need to
then people
leave.
can't figure out why. I think there's two reasons. One is because they have this lovely volcano that gives them a lot of sulfur in their water. So they're drinking water that naturally has sulfur. And I think that's also something good to do, like volcanic water. We buy some Hawaiian volcanic water here that
Do
we
you?
enjoy. Yeah. So
Good for you.
so that
Now,
just gives you the sulfur. So it's the sulfur and then also the deuterium depletion because the water that comes off of the glacier typically is like 110 parts per million. So it's also lower. 155 is the norm. Is trying to look at something less than that. But actually, you don't want to have your deuterium be too low. So it's just like iron; it can be simultaneously toxic and deficient. Because what I'm figuring out is that the body actually sequesters the deuterium in the extracellular matrix. It traps it in that gelled water. And this gets into Gerald Pollack's work because Gerald Pollack talks about the battery, right?
fourth phase of
Yeah.
water.
Fourth phase of water, which is the gelled water, which lines all the blood vessels. And the gel actually creates a battery. And Gerald talks about this and he elegantly demonstrates it in his experiments. Um, and so the water pushes the protons out of the gel into the circulating blood. If you think about the blood lining, the gel lining all the different vessels, and all of those places where there's gel, the protons are being pushed out and being picked up by the blood, but the deuterons are being stay behind for the same reason that they don't go into the gas phase. They stay with the gel. They tend to stay with the gel, and they don't leave. And so what this does is it depletes the deuterium in the blood while sequestering the deuterium in the gel. Does that make sense?
Yeah, it's like two totally different functions, right? Or just
It's
goes
simultaneously
over
doing
here and
both.
over here. Right.
Yeah, because keep the deuterium inside the gel, and then let the protons go out. And so what's in the blood has low deuterium, and that's a way to keep the lower deuterium in the mitochondria through that trick. And of course, if you don't have enough sulfate, you don't have enough gel. That doesn't work. The battery is weak. It doesn't work very well, and now the blood ends up with extra deuterium. It's very simple.
As you put this all together, this seems like your PhD is way more than in biophysics and not just the other areas that I mentioned when I introduced you. You seem to know a lot more than biophysics. What your degree is in, what you're involved in is physiology, chemistry, biophysics, electrical engineering, electricity,
Yeah.
correct?
Right. Yes.
Have you looked into the magnetic side of this? Magnetism? Does
A
magnetism
little
play in
bit.
here?
I am
Hmm.
interested in magnetism, but I haven't really dived into that space yet. I'd like to, and
It's
of
an
course,
interesting.
cosmic
It's an
physics as
interest.
well. Yeah, there's
Plasma
some.
physics.
Yeah, I mean, yeah. Well, all of those exotic physics domains, I don't know enough for sure, and I don't know if I'm going to
It's
have the
complicated.
energy to
Yeah,
get
or the
into that
time in a
because
lifetime.
I know the
What you got in
biology.
this lifetime is
Biology
wow.
is so fascinating and it's so complicated and it's a giant puzzle and I love a puzzle. So I'm very kept very happy with the biology puzzle, just trying to figure it out. But I think I'm making a lot of sense out of the deuterium system and then out of the ways in which glyphosate disrupts it. And partly it's just through disrupting those gut microbes that make that hydrogen gas. Because if you just do that, you've got a big problem
What do
with the
we
whole
do?
deuterium system.
What do we do about the gut microbes? What is your take on this?
Well, you got to
What
get rid of the glyphosate for sure. And of course, organic diet is, I think, the most important thing you can do for your health is to have a certified organic diet. And you mentioned sulfur earlier. I didn't tell you which foods because there's a lot of great foods that are good sources of sulfur. And I try to eat a lot of those. And animal-based foods like the seafood, fish and clams and oysters, those have lots and lots of their micronutrients, including sulfur. Eggs, organic eggs is a fantastic food, very nutritious. On the plant side, there's cruciferous vegetables like broccoli and cauliflower and Brussels sprouts, and then cabbage, and then also onions and garlic. I eat a lot of onions and garlic. I also encourage people to use a lot of fresh herbs in cooking. So basically all fresh ingredients, lots of herbs, lots of spices even. I
You use
really enjoy the
turmeric?
spices.
Turmeric?
Turmeric
Use
is very,
turmeric?
very healthy.
Turmeric?
Yeah, very healthy. And garlic, I eat a lot of garlic, and also um, ginger and garlic, both really, and they make your food delicious too. So I think people should really be encouraged to
Are
be
you a good
generous
chef?
with herbs and spices. My husband is.
Is he?
He's the big cook in the family.
I feel like I should come over after what you're talking about. Heck.
Yeah, he's great.
What do we do about the water? We depend on the water for everything.
Yeah, I know. It's a problem, it's because the reverse osmosis, as I said, can take out the glyphosate, but it'll take out all the minerals as well. So you've got to put them back in.
And in terms of the deuterium, how do we get deuterium depleted water? What do we do?
You can buy it. I think it's made in Russia. I don't think they know.
I'm part Russian. I don't have a problem with it. My great grandparents are from Minsk. I'm not going to be embarrassed about that.
So the Russians actually were the ones who figured it all out. It's Hungary and Russia and Ukraine. Those are kind of the three countries where they figured out this whole thing with the deuterium. And they make this light water, which is like 10 parts per million of deuterium, so very, very low. And you want to sell it with as little as possible, but then you don't drink it straight. That would actually probably be a bad idea, to drink it straight. So you mix it. I try to do every day 1 glass, 2/3 of regular water and 1/3. So it's 1/3 of a cup of light water that I've been drinking every day for a long time. So I buy it on the web, and just to get you a glass of water that has a little bit less deuterium than normal. And then I eat a high-fat diet.
So I'm not trying to impose this translation onto the audience or to you, but is this also used homeopathically almost? Because you do a little bit of this water and then do you have RO water, or do you put it in distilled water? What do you mix it with?
I use filtered tap water, 2/3 cup filtered tap water, and then 1/3 cup of deuterium light water, to make it basically like a glacier water, because I don't want to drink something that's not natural, so it's basically simulated glacier water. And you can buy glacier water on the web as well, and they're both expensive, I think. I don't know what the price of glacier water is, but it's available. But in eating low-fat, low deuterium foods, but also just getting rid of the glyphosate, because glyphosate is what makes the deuterium toxic. Just like the iron, glyphosate messes up the whole system that normally knows how to handle deuterium. And actually, deuterium can make the bones stronger. So it's actually healthy in the bones. There was a fascinating paper written recently about seals, and they found out that the seals had twice as much deuterium in their bones as the normal amount, for example, in seawater. They had concentrated deuterium in their bones, and that's because it's going into the collagen matrices and into that gelled water. It's getting trapped in those outside of the cell, these spaces that are outside of the cell, so they're far away from the mitochondria. And it's not toxic there. It actually is helpful because it makes the bones stronger. And these seals can go down to really deep water and handle that water pressure. And they suspected that might be the reason why they were concentrating the deuterium in the bones.
I never thought seals had bones. When I think of a seal, I'm like, where are the bones? You know what I'm saying? I don't see any bones.
They don't walk around
but
yeah,
you don't see the bones. There's no bones that I see. Wow. That's really very, very interesting. I'm sure you've heard of sulforaphane.
Yeah.
Correct?
Yeah, that's a nutrient that's found in broccoli, for example.
And some people are taking the sulforaphane tablets. Some people are growing the broccoli sprouts.
Yeah.
What do you think about that? Could that help?
It's probably good. Well, the broccoli sprouts I would recommend. I don't like tablets in general. I don't actually take any pills, you know. I consider that to be extremely processed food. So I try to avoid pills. Then also
Got it.
the gel cap could have glyphosate in it because it comes from collagen.
Oh my God. Isn't it usually made of gelatin?
Gelatin has lots and lots of glyphosate. I mean, has
Oh
lots and
my
lots of
God.
glycine, which probably means glyphosate. And in fact, Anthony Sempsel has tested. He tested Jello, that the product Jello, and he found glyphosate, pretty high levels of glyphosate in the Jello.
Oh my God. Did you ever know a man named Ray Peat?
Yes,
Okay. Well, I interviewed him a couple of times. He was fascinating.
uh-huh.
But he, in the old days, before glyphosate really took hold of the whole ecosystem and the environment, really took over, he had highly recommended gelatin, pure
Yeah, yeah,
gelatin. And
right.
now I don't know that we can do that.
Well, that's the thing. It would be a very healthy food if not for the glyphosate, you know. I mean, the Chinese, they really love gelatin. They like this shark fin soup, right? The shark fin is like lots and lots of collagen, and then the Chinese know that that's good for you.
I wonder,
And birds
I
feet,
wonder,
they have the chicken
I'm
feet,
gonna
right?
faint. I'm gonna faint with the feet. I
Yeah.
always say if someone puts a fish on the plate, I say, please don't show me the eyes. Don't show me that face. I can't look at it. You know what I
Yeah,
mean? I
the
can't.
Chinese are more comfortable with
Oh, they'll eat it. Yeah, yeah. It's anything goes. Okay,
yeah.
anything goes. But I was wondering, on behalf of the audience, are there certain areas of the world that have been tested? I don't even know how this could be done, but over the last 10 years or 15 years, has there been tests like you'll see more of a preponderance of glyphosate in this area versus that area versus Europe versus Asia versus the US or Canada or Australia,
Well, I mean, there's certainly some knowledge floating around about how much glyphosate is used in different places. I think the United States and Brazil are kind of competing for number one, number two as
Oh
far as
my
the most
God.
glyphosate. Those two countries. Europe uses less, and actually there was a Canadian. So the Canadians actually did tested a lot of different foods. Um, it was my friend Tony Mitra, who is a Canadian citizen but originally from India, and he was really hung up on glyphosate, and he was harassing the government for many years to get them to test for glyphosate in the food supply, and they finally did, the Canadian government. And he produced a book called Toxic Foods, let's see, of North America, I believe was what it was called, or something
Really?
like that. Yeah. Because they looked at Canadian foods imported from the US, foods coming in from Mexico, from Europe, different food sources. And then they tested all these different foods, like over 8,000 samples of different things for glyphosate. And then they gave him all that information. He made that book out of it, out of the information that he had. And so I looked at a lot of the numbers, and I was surprised by some things, which was, for example, the legumes, chickpeas, garbanzo beans, lentils, those foods. They had many of the highest levels of glyphosate were found in those foods, like higher
Oh
than
my
anything
God.
else. And that's because they're sprayed right before harvest as a desiccant.
Oh,
And
that
that's
was
true for
another
wheat.
thing. Oh my God, in your book, talk about that because that was shocking, both with fruit, how they're sprayed right before they are ripe. Talk
Yeah,
about that with wheat.
well,
Oh my God.
it ripens the sugarcane. So they spray sugarcane right before harvest. They spray wheat and barley and oats, and then all these legumes like the garbanzo beans and the chickpeas and the lentils, and some of the seed nuts as well. So many different products are sprayed. The crop is sprayed right before the harvest, and that of course goes into the seed actually preferentially. And so like wheat germ probably has the highest levels of glyphosate compared to other parts of the wheat, which is the healthiest part of the wheat germ. And I think the gluten intolerance epidemic that we're seeing is directly tied to the glyphosate in the wheat. I believe that, and I've written about that as well. But where was I going with that? So yeah, the legumes, that's something to watch out for. So if you have hummus, for example, which is a food that I
I was just
like,
going to say, there went the hummus.
yeah, you got to have it organic. If you get hummus, it's got to be organic. I feel.
Do you think
One
it
of the foods
really, do
especially.
you think it really matters? Like, for example, because as we know, the GMO, genetically modified seeds, the crops can, by the wind, go from one location to another. Can't glyphosate go from one
Yeah, it
location
certainly
to
can,
another?
and often, and in fact, Canadians found glyphosate in several different organic foods. It wasn't not necessarily the case that because it was organic, it wasn't there. And that probably doesn't mean they're cheating. It's just that it's everywhere. It's in the rain. I actually collected some rain
Oh my God.
in Cambridge, where at my office at MIT, and I sent it to Anthony Sample, and he tested and he found glyphosate in it in the rain in Cambridge. So, it's and of course the manure, because the cows are eating lots of glyphosate, and you use the manure you don't have to use organic manure on the farm. So you're going to get it from that as well. So the organics are not necessarily completely free of glyphosate, but certainly on average, those from the Canadian study, the organics came out much better generally, and especially with the legumes, much lower levels. And also they found that foods imported from Mexico were lined up with foods imported from Europe, much less
Oh,
compared to
I
Canada and the
believe it.
United States. So, if in doubt, if you can't find organic, buy it from Mexico, which is ironic because we sort of think of the Mexican food as not necessarily being safe, right? It's better. And Mexico has actually been working really hard to ban glyphosate. They were planning to do it by April of this year, which has already passed. And
Well,
the
they have a
whole
new
time they were
president. I hope she does it. I hope she
Yeah,
can
well,
do
the
it.
whole time they were trying, US kept harassing them and saying, "No, you can't do this." We're threatening them
Isn't
with
that
trade.
incredible?
Incredible. I was so upset with the United States. We ought to follow their lead and think, "Oh, if they're doing it, maybe we should consider doing it too." But no,
But
we just try to stop them.
who has dominion over that decision in the U.S.? Well, bringing food from Mexico in here, is that the USDA? Is that the
Department of Agriculture, probably. I don't know. But we were concerned. Our country was concerned that they would not buy our corn because it would have glyphosate in it, and they would refuse to buy
I
it.
don't blame them.
So
Yeah.
we want to protect our toxic corn by telling Mexico, that threatening that we won't, just to it's just really frustrating that our country doesn't seem to think that glyphosate's a problem, despite their extremely high levels of autism in this country.
People are at their homes. I see this all the time. Gardeners and homeowners allowing Roundup and weed killer to be sprayed all over their yards. I
know.
I would not allow that to happen here where I am. I said, "Do you understand there's bunnies here, there's birds here, there's
Yeah.
insects here, like there's plant life here?" No. Because it spreads all over the place. They really don't know, and of course, a lot of gardeners just aren't. I mean, they don't have the education to know what it does, and that's what the market sells.
No, I think the government is being very deceptive in saying that it's safe. And then people tend to believe the government. They say, well, the regulators say it's safe, so it must be safe. People have learned that it's a very safe chemical. And it's hard to unlearn that once you've learned it, I think.
Well, again, that's that safe and effective slogan.
Exactly.
Yeah. What is MIT? I mean, you're very blessed to be able to focus on the kind of research that you do. How does MIT receive what you're doing?
Well,
Is there controversy? Or is there friction or backlash or just disassociation? Like how is it managed at the university?
I've
To the
been
best that you can speak to it.
Well, I've been very impressed with them, actually. I've been very appreciative because I've been wondering all the while whether they're going to try to, cut me back, like to say, you can't go there, or you're stepping out of line. And they never did. They never did anything. So I think they've been incredibly supportive, and I'm very grateful for that.
That's great. That's great. Are there any other research scientists at MIT that you find very interesting and that are going to be part of this puzzle that you're putting together?
I'm
there
sure
people
there are
there?
researchers at MIT that are doing interesting work related. There's some good work on the microbiome, for example, and we have a really strong biology department. And certainly some of the papers I find are from MIT researchers, but I don't interact with them. I actually do try to minimize for fear that it might backlash. So I do try to minimize my interaction with the people.
Maybe I asked the wrong question here.
Yeah.
Your work in electrical engineering and computer science, before we wrap up here, just talk a little bit about these all seem Very different. Why did you go into biophysics? Why did you go into electrical engineering? Why did you go into computer science, if you don't mind me asking?
Well, yeah, biology has always fascinated me from the time I was a child. I used to read books about biology as a child. Always wanted to be a biologist, actually, and so I studied biology at MIT for that reason. And I actually got into the PhD program in biology, and I spent a year. And in that year, I was working in a biology lab, and I was absolutely miserable and absolutely incompetent. So I got really frustrated because I couldn't make my experiments work during that year. I love biology, and I did very well in all the courses that I took. I always got an A, in the courses in biology. And I got taught by some special people like Salvador Luria, who was a Nobel Prize winner on the mitochondria, on the citric acid cycle in the mitochondria.
Wow.
I took a course from him on that, which was great because I've really used that in my work now. It took a long time before I actually needed it, but I'm glad that I had learned that way back when. But anyway, I in the laboratory, I was really I didn't enjoy it. I didn't do well at it, and I got really discouraged. And I just decided that I was actually really crushed. I decided that biology was not going to work for me, and I needed to do something else. And it was right at the time when computer science was just starting. At that point, we didn't even have a department. We didn't even have courses. I think we had a couple of courses in computer science just opening up at MIT at that time, and and so I got a job as a programmer with no experience at MIT
Wow.
Lincoln Laboratory at that point. And I dropped out of graduate school and I went to work. And actually, I was working, they happened to be doing research on digital signal processing, digital speech processing. I started working on things like speech recognition and voice encoding algorithms and things like that. And while I
Wow.
was working, I worked for 10 years and did and took courses one at a time in the AECS department over that 10-year period. And then I always got an A in the course, and then I applied to MIT for the computer science, electrical engineering and computer science program. Kind of on a lark because I didn't think I could get in with a biology background, but luckily they accepted me, and then the rest is history. So computer science suits me better. I really loved writing code. For many years, I wrote lots and lots of code.
What kind of code? What did you write? What language?
Well, computer code in various languages, but we were writing programs to teach the computer how to communicate with people using natural speech. That was my specialty.
Oh,
Uh,
wow.
and so basically, Amazon Echo and Siri on the iPhone are examples of products that came out of the research that we were
Oh,
doing. We
my
were among the
God.
first to develop what we called spoken dialogue systems, where you communicate with the computer, for example, to book a flight or to ask about the weather. I mean, all these different applications that we developed over the years. And
Does this have to do with voice recognition as well?
oh yeah, absolutely. That's what
Yeah.
it is. Yeah.
Mhm.
And of course, I had no idea at the time that it would become a surveillance thing, which really is frustrating to me that now the computer can listen in on your conversation and then it can find out a lot
Can
about you.
is, not can, is
Yeah, I
apparently.
know. Yes, that's really scary, actually. I had to reread the book 1984 just to remind myself of, because I had read it way back when, but it's sad that the field that I worked so hard on is being used in these ways. And I also hate these online telephone interactions where you can't get a human being; you have to keep talking to the computer.
I
So
know.
I'm not pleased with how my research has turned out. I was, of course, just interested in I was interested in speech and how humans. My PhD thesis was on an auditory model for how the human processes speech, human auditory model for speech understanding. So I managed to do some biology during my PhD thesis, but yeah, I worked in computer science, really strictly in computer science for many years, and then I made a major shift in about 2007, which was because of the autism epidemic. I just felt like I've got to figure this out, and because I couldn't stand it that the government was ignoring it, and every year the rates were going up, and I could see that that was going to be a huge crisis in another 20 years, which is we're coming up on that now. So
Where did the electrical engineering come in? Tell us about that.
the department is electrical engineering and computer science, and
Okay.
I think I would not qualify as an electrician, for example.
You
I mean,
probably blow up somebody's house, for God's sake, with too much
some
knowledge.
courses, but that wasn't my strong suit. I was mostly in the computer science aspect of it. Yeah.
Wow. That's a lot. So if it's up to you, right? Someone passes the baton to you and says, okay, come up with a way to get rid of glyphosate that already exists. Let's say all of it stopped, no more manufacturing of it. Now what? We still have to get rid of it.
Yeah, it's going to last for a while because it can stick around for a long time under certain conditions.
What's a long time?
Well, there was a study in Canada on trees that had been sprayed with glyphosate over a decade beforehand, and they looked at the tissues of the trees and found glyphosate in them. 10
God.
years. So under certain circumstances, it can break down quickly. If there's some microbes that know how to metabolize it, for example, and also sunlight can break it down. And I mentioned chlorine. Chlorine can break it down. So there's some things that can break it down, and there's some microbes that can do it, but it can get trapped in. For example, interestingly, there was a fascinating paper that showed they were looking at murky water, and they put glyphosate in the water, and then they detected to see how much glyphosate was in it after a period of time. And the glyphosate went missing, like most of it was gone when they tested the water. And then they found out that it actually had just gotten sucked up by the organic matter that was in the water. So when you put glyphosate in a waterway that has a lot of organic matter in it, the glyphosate gets sucked up by the organic matter. And then if the animals that eat the organic matter get a huge dose of glyphosate, and that's what's happened to the manatees, I think, in Florida. They're very sick. They've been getting sicker every year.
Oh, that's sad. That's sad.
Yeah,
the whole thing.
Because there's lots of glyphosate in the Florida waterways.
Do you feel your message has gotten out enough?
Not enough, but it's gotten out. I'm actually pleased at how many people now know the word glyphosate. In the past, almost nobody, right? Not that long ago. So the word has gotten out. I really appreciate Zen Honeycutt. I don't know if you know Zen Honeycutt. Moms Across America. She founded the organization called Moms Across America. She's doing really good work. She's fearless, I would say. And what she does is she picks a particular topic, like for example, fast food. And she has the Moms Across America. She has a whole team of moms who will get samples of fast food and send it off for testing for glyphosate. And then she gathers the money from funding a donation. She gets the money to pay for it. And then she gets those samples, gets the glyphosate numbers out. And then she goes to the government and says, hey, look, these foods are toxic. She's been doing that she did breast milk, fast food, school lunches. She got all these school lunch samples. They all came out terrible. Like 95% of the samples were contaminated. Some had very high levels, the bread, for example, gluten intolerance, you've got the glyphosate in the bread.
Yeah.
And she's doing Girl Scout cookies now, and she's done
oh my God,
baby formula that she did.
For sure, baby formula. They have some bad stuff in baby formula. Bad.
I know. So she looked at the metals, toxic metals in baby formula very recently, actually. And we have a show we do together called New MDs, the New MDs. Moms,
great.
Doctors and scientists. And we've been doing it now for
fantastic.
Like a year and a half.
Give us your URL for that. What's the URL? Do you remember?
I don't have it off the top of my head, but I can send you the link. Yeah.
I'll add it to the write-up about you.
Great.
That's great.
Yeah.
So how do people find you on YouTube and Apple?
Yeah, I have a webpage, stephanieseneff.net, which has some materials on it. My book, I definitely recommend reading my book. And of course, if you just remember my name, Seneff, you can probably find a lot of interviews like this one. If you can remember my last name, Seneff, on YouTube, or all kinds of different interviews and presentations are available on the web.
You're very brave to do the level of research that you're doing, and to be able to speak it in a way that, even though it's at the 100,000-foot level, that puts it together also for other scientists, doctors, people that are studying and need to know. There's so much to pay attention to. It's staggering. But this is of all of the chemicals, would you say this is one of the biggies? This is one of the biggies. I
think so. And it's two reasons, maybe three, but one is that we think it's safe, and it's a slow kill, so we don't notice that it's poisoning us. And then, of course, it's so pervasive. I mean, the big thing is that it's so pervasive, and we use it carelessly, and people can just go down to the local store, buy it, put it on the dandelions in the yard while the kids playing in the yard. They don't think anything of it, because it's supposed to be safe. So having this false message of security about it, and then having it be so convenient and so effective in killing the weeds growing in the walkways, it's so effective that it's really hard for you to you want to believe it's safe, because otherwise you've got a much harder task to get rid of those weeds. And of course, they argue that we'll have food shortages if we don't use glyphosate, like it's essential for the agriculture. I don't believe that, of course, but that's what the farmers will say. They've gotten used to using it. And actually, if you don't use the glyphosate weakens the plants so that they become less resistant to the insects and the fungus, all these other problems that they come up with. And of course, they get nutrient deficiencies as well, mineral deficiencies. This all affects the health of the plants and even a greater susceptibility to drought. There's many ways in which the glyphosate is weakening the plants that are exposed to it, so that the crops in the soil, of course, is also getting wrecked by the glyphosate. The earthworms they're getting Parkinson's disease from the glyphosate, so they can't do their job. So everything in agriculture is deteriorating because of the glyphosate. And I think it's even contributing to climate change because it interferes with photosynthesis and reduces the amount of carbon dioxide that the plants can take out of the air. So that's a way to get the carbon dioxide levels high and causing global warming.
Well, I don't know about that part, but that part I've spent, I don't know, a couple of years and 37 shows on it. I would say that's the only part, that connection of that particular connection you're making to causality. That's where I disagree with you, but that's fine. This is your view of it.
Yeah, well, I do think
on the climate part.
They're approaching the problem wrong in the way they're dealing with climate change. It's not the right way to deal with it.
Yeah. There's several factors. I think just in ending, I think we should end this properly. Well, number one, I'm because I love whole systems and looking at the gestalt of what's happening. We have to stop geoengineering. That's been going on for at least 45 years. That's a 24/7 day thing that's going on, dropping chemicals and other toxic stuff on humanity, plants, animals, everything, the biosphere. And then when you add your particular focus on the ecosystem, that's a whole other thing. And then all the other chemicals and the water supply. Then when you start to add all that, you're going to have massive ecosystem changes, and then when you omit, when the people that are doing the talking about climate change deliberately omit the solar cycles of cooling and warming and their impact. Yeah. So that's the complexity of this thing, is that even to talk about it it ends up being political when it's not. We should be able to look at it the way you have gone into all these different systems to look at what glyphosate, I can't even pronounce it, glyphosate is doing and the disruption that it's causing. You're really a hero. To me, you're a hero. You remind me of a kind of Gandhi in the agriculture and health space, and you also remind me of Vandana Shiva, because Vandana Shiva,
I know her.
Who's do you? Oh, okay, with
Yes,
she's a Gandhi
She's
in her
great.
area, biodiversity, and I
Yes,
think
she's
when you
so
put
well-spoken.
yeah, you both are. I mean, you're just at the 100,000-foot science level trying to translate down to us people. But when you take her work and you take your work and you take some of these other people and you start putting together the whole of what's happening, do you think in your lifetime we have a chance to get glyphosate out of the system?
I think we have to. If we want to survive long term, I think we have to. And I do think enough people are waking up, and you need to get the political people to wake up. But of course, any individual can make a difference by buying organic, telling their neighbors and their friends and their family buy organic, getting the message out. We can do this grassroots bottom up, and eventually there will be a groundswell that will just force the government to start to think about, we got to do something different. And as the autism rates keep going up and people keep getting fatter and fatter, we're going to at some point recognize that there is something wrong with our food supply, and we need to fix it. Sure. And it's clear to me that glyphosate is the most common It's the only chemical I know of that consistently shows up in like 95% of the samples, you know. There's other herbicides that are also toxic, but they don't show up nearly as often as glyphosate does because it's considered to be so safe that it's used everywhere. It's just used way too much, and it shouldn't be used at all. It should be taken off the market and stop the manufacturing. And that's where we're
Well,
going to get to at some point if we don't, unless we die out beforehand, because we're going to kill
well, that's
ourselves
a
off
concern. I
rapidly.
mean, it's a concern when you start adding all the elements, the geoengineering and all the chemicals and toxic materials in that. Then you start to, the how many vaccines a person has to have to, quote, satisfy the authorities. And then you talk about this virulent chemical, okay, that has a slow kill. And you start to add, and then the infiltration of the water. What are we going to do?
And you look at the fertility rates, you can see the sperm are going down, the sperm are losing mobility, and more and more people are infertile, they can't produce kids. All you need to do is just to prevent us from being able to reproduce, and then we're dead in the water, we disappear. And
that's what
where
Elon
we're
Musk
headed.
says.
That's where we're headed. Yeah, I think.
Sometimes,
unless we do something different, so we have to turn it around. And
don't you think most people want to do something different, but are powerless with respect to the authorities who are controlling the whole thing?
That's amazing.
That's the rub. I think most people are good. Most people are good.
Well, the censorship is amazing. They just won't let the message get out. And the chemical industry is so powerful, and agrochemical and also pharmaceutical. I really don't like the pharmaceutical industry either, for their lobbying effects and just how much they can control the government to not do what they need to do.
I got to tell you this one thing, you in the audience. In August of last year, I'm coming back from a trip. I'm in the Charlotte airport, and I'm sitting down, and I checked something on YouTube, and I got a strike from YouTube for doing a tribute to my late Dr. James Privatera, who used to cure his cancer patients. And so they took it off. This is a tribute. The guy's dead.
Yeah.
A tribute to my late doctor for 30 minutes. Medical misinformation, dangerous information. And it's a tribute to somebody who's not even alive.
Yeah.
Does that tell you the level of censorship that's going on?
Yeah, it's amazing. It's really amazing. I've of course been censored a lot, and I figure that's just the way the game goes. So,
well,
it's on people like you to help to get the message out. So.
It's a pleasure and a divine honor to be part of your censorship club, because I have been too.
Yeah,
I produced a 2-hour special on the Constitution. It was blocked everywhere with one of the greatest minds in the Constitution, Dr. Edwin Vera. It was totally blocked on YouTube, blocked on Facebook, blocked on Instagram, completely censored. Even before Elon Musk was at Twitter, what became his company, I watched it be shadow banned in front of my eyes.
Yeah.
And I have to tell you, it's still, it's not gone away. It's not gone away totally.
Well, we've got the alternative media, and they're helping us out. So
yes. So I want to thank you for being here and dedicating your time to join us on It's Rainmaking Time. I really appreciate it. And for all of you who, again, should pick up Stephanie's book, Toxic Legacy, and go to her website, StephanieSeneff.com or .net. .net. And for those of you, I just want to say this at the end of the show, who would be interested in having your communication skills sharpened, your solution delivery training, bringing a solution and a discovery into the world. That's been my background, is helping other people do that. And also in communication, whether you're packaging a letter, you're packaging yourself, you're packaging some type of discovery or a product or a service, call the Rainmaking Company. Go to rainmaking.com. And we have many, many videos there for you to see and services to offer to you. And we thank you so much for joining us. And also come back to It's Rainmaking Time for more of our segments. We do a once a month special. Thanks so much, Dr. Seneff. Thank you so much.
Thank you so much for having me.
It's Rainmaking Time. Stand by.